Hi everyone. So in this video we are going to study about dice and cubes. So it is a very simple topic. So I hope you must have seen a dice. What is a dice? Dice is a cube only. The dice that we use to play games. You might have played Ludo. So in that we use dice. So that is a cube only. What do you mean by cube? That all the sides are of same size. All the sides are of same size. Let's just say if this side is A, so length is A, breadth is A, and even the height is also A. So all sides are of same size. That is what we know as a cube. And area, surface area, volume, all those things we have already seen. But here we are not going to cover the geometry part. Here we are going to see the some other reasoning part of dice and cubes. So we will see that part. Now let's just say I click a picture of a dice. I click a picture of a dice. So how many sides you will see at a time? Maximum how many sides you will see? You are clicking a picture such that in the picture you need to see the maximum sides. So how many sides you can see? This will be the picture only, no? So in 2D you can see only maximum of 3 sides. This you can consider this thing as a cube only, okay? Although this is a cuboid, but let's consider this as a cube. So if I click a picture from here, so what I will see? I can see this side and this side, also the upper one. I am clicking the picture from here, from the upper side. So 3 sides I can see at 120-degree angle. In 3D the angle is 90-degree, but if you show it in 2D, the angle is 120 between them. Because in 2D there is 360-degree, total angle is 360-degree. Although in actual this is 90-degree. In actual this is 90-degree. But in 2D you have to show as 120-degree angle. So at a time you can see only 3 sides, right? At a time you can see 3 sides only. So whenever they show a problem of cube, and if they are drawing the diagram, they will draw the diagram like this, where only 3 sides can be seen. Okay. So in questions you will see the diagram to be drawn like this. And here for better visualization we have shown that the cube is actually looking like this. Okay. So now have a look at your room. Now your room is cuboid. Okay, most probably it is cuboid, but let's consider as a cube only. Now our task is to open the room. So what I have told, that wherever you are standing, that surface is 6. Wherever you are standing or wherever you are sitting, the below surface, the earth is 6. The roof is 5. Sides are 3 and 4. In front of you there is 2. Behind you there is 1. Got it? In front 2, behind 1, 3, 4, surface 6, upper 1, 5. Now we are opening your room. That means I will push the wall that is in front of me. I am pushing the wall that is in front of me, and that will fall down. This will be 2, right? This is 6. This is where I am sitting, and then I have pushed the wall that is in front of me. 3 and 4 are there this side. I push them back. Okay, both 3 and 4 have been pushed. Both 3 and 4. So 3 will fall on this side and 4 will fall on this side. Above me there is 5 and behind me there is 1. So what I do, I push 1 back as well, and also 5 will fall down, right? 1 and 5 are there. So 5 I open up and 1 I push. If 5 I open up, that will go above 1. Let's just say I open up the 5. So 5 is above me. I open that up. So that will go above 1. Say yes or no. And then I push them both back. So this will be 1 and this will be 5. Did you understand how did I open the room? You don't need to look at this diagram. Look at your room. Pushed them back, opened up and then pushed back. Understood? What did you understand from here? Which sides were opposite? 1 and 2 were opposite, right? So this and this side is opposite. Say yes or no. See in the diagram, 1 and 2 were opposite. 5 and 6 were opposite, right? 5 and 6 were opposite. So this and this side were opposite. What else you see? 3 and 4 were opposite. So this and this side were opposite. Right? So what did we understand? 2, then we have to leave one number and then the other number. Those are opposite. 2, leave one number, the other number. Those are opposite. 6, leave number, 6 leave one number and then the next number, those are opposite, and the rest 2 will be opposite only. So these are opposite. And if let's just say 6 and 5 are opposite, so 6 and 5 are opposite, and I ask you what all are the neighbors of 6. 6 and 5 are opposite, so 6 is the neighbor of, apart from 5, everyone. 6 is the neighbor of in front, behind and sides as well. So 6 is the neighbor of 2, 1, 4 and 3. 6 will be neighbor means it should touch those walls. So 6 is touching 2 as well, 6 is touching 1 as well, 6 is touching 3 as well, and 6 is touching 4 as well. So 6 is the neighbor of everyone apart from 5. Say yes or no, everyone apart from 5. So I can write 3, 2, 1, 4. Same goes for 2 is the neighbor of everyone apart from 1, because 1 is opposite. So everyone apart from 1. So that is neighbor of 2. 2 is the neighbor of 3, 5, 4 and 6. Now similarly you can write all the neighbors, right? 1 is the neighbor of everyone apart from 2. So 3, 4, 5, 6. And in that manner you can keep on writing. So are you understanding the point? How you can open up a dice? And what is the conclusion that we have made? That if you go in a line, 1 leave one number, the other one will be opposite. 1 leave one number, other one will be opposite, and the rest 2 will be opposite only. So this is the concept, how you open up the dice. So this is one way of opening the dice, only one way. Only one way. There could be many other ways as well, right? There could be many other ways as well. Let's just say this is my 6. So what do? I push this wall. I push this wall, and then the wall that is right ahead, that also falls down. That means if this is 6, then it can fall down in this manner as well. That I push this wall 3, and then this also falls down 5. In this manner as well, I can also open up, and this goes 4, and then wall in front, that is 2, and wall behind, that is 1. So there could be many ways, but one conclusion you will always make, that what did I tell you? In a straight line, 5 and 6 will be opposite. Yes, 5 and 6 are opposite. 3 and 4 will be opposite. Go in a straight line, 3 and 4 will be opposite, and 1 and 2 are opposite. 1 and 2 are opposite. Understood? So always there will be, these things will always be coming. 5 and 6 are opposite, 3 and 4 are opposite, and 1 and 2 are opposite. So always in a straight line you will go, you will drop one number, and the other two numbers will be opposite. Understanding this point? Okay. So there could be n number of ways of opening a cube. A lot of ways will be there. But always there will be one common thing that we have already seen, the opposite side. Also there is one more conclusion. What is that? That these 3 and 4 can slide anywhere. 3 and 4 can slide anywhere. So let's just say this is what we saw. 2, 6, 1, 5, right? 2, 6, 1 and 5. And this is 3. If I make 4 here, this will also be one of the ways. Because these are on the sides, right? 3 and 4. They can open up with anyone. Let's just open 3 and 4. I have opened it 3 and 4, and I stick them to 1 and I stick them to 1. I open 3 and 4 and I stick them to the wall behind me. It can open, right? So one can be neighbor of 3 and 4. Say yes or no? And I can open up 3 and 4 to the other side. So 3 and 4 will be neighbors of 2. I can open up 3 and 4 to the upper side. So 3 and 4 can be neighbor of 5. And I can open up 3 and 4 to the downside as well. So 3 and 4 will be neighbor of 6. So 3 is the neighbor of 2, 6, 1, 5. So they can slide anywhere. So 3 can come here as well. What do I mean by that? Try visualizing it. I have opened this wall to the wall in front of me. 2 is the wall in front of me. So I have pushed this wall to the wall in front of me. And what about 4? What I have done? I have pushed 4 to the wall behind me. Are you able to visualize? I have pushed 2 sorry, I have pushed 3 to the wall in front of me in this manner. I have pushed 3 in this manner and 4 in the backward side. So this diagram we will get. So these can slide. I am just putting that these two can slide upper side and downside. Both can slide. So they can slide anywhere. Okay. So let's see something that will help you to visualize it more. Not visualization, that will help you to grasp the concept more. So this was our basic structure. That was this one. 2615. 2615. Here there was 3, here there was 4, so I told you we can slide anywhere, right? Now it's not necessary that 3 and 4 only will come here, anything can come. Let's just say if I am putting 2 here, basically I can open 2 near to 3. I push this wall not downward, I am pushing this wall towards the left side. I am pushing 2 towards the left side. So the basic concept is, from here what did you get to know, that 2 is opposite to 1. So 2 should be opposite to 1. So this will show the opposite one. This will show the opposite side. 6 is opposite to 5. So if I am putting 6 here, then where 5 will come? Here. 3 is opposite to 4. So if I am putting 3 here, where 4 will come? Here. That's it. So there can be n number of ways of opening a dice. Okay. What if I do this thing? So this and this were equal. Now what I do, if I put 2 here, so 1 can come here as well and here as well, right? No, I should not put 2 here. This is not even possible, because let's just say if I put 2 here, and then where would 1 come? 1 has to come here, right? Or it can come here, and then let's just say I put because 2 and 1 were opposite. If I put 3, so where will 4 come? 4 has to come here, right? Because 3 and 4 are opposite, so there would be space of 1. So this thing is not possible. This is not possible. So I can slide these. I will slide this one. Okay, so 1 and 2 are opposite. 3 and 4 are opposite. 1 and 2 are opposite. 3 and 4 are opposite. So 3 and 4 are opposite, and 5 and 6 are opposite. So 5, these two can slide anywhere. So 6. 5 and 6 are opposite. 1 and 2 are opposite. 3 and 4 are opposite. 5 and 6 are opposite. So those which are opposite, they will remain the same only. So there can be n number of ways putting. There will be n number of ways putting this up. Okay. Now next, what do I do? I try to do something like this. Can I open in this manner? So 2 is opposite to 1, or let's just say 5 is opposite to 6. So 5 is opposite to 6. And then 3 is opposite to 4. 3 is opposite to 4. And then rest of the number will be opposite only. So 1 is opposite to 2. You just need to find two opposites. 5 is opposite to 6. 3 is opposite to 4. And 1 is opposite to 2. That's it. So in the question, dice will be given, diagrams will be given. You can find the opposite things, and based on that you can make your conclusions, and you will be able to solve the problem. That's it. This is the most important point, that go in a straight line, and by dropping 1 you will get 2 opposite. Dropping 1 number, let's just say I drop 2 numbers, so 3 and 4 are opposite. 3 will be opposite to 4, 5 will be opposite to 6, and 1, 2 are opposite to each other. And if 5 is opposite to 6, that means 5 is the neighbor of 1, 3, 2, 4. Right? Let's solve some problems. An open dice, open cube is shown. You have to make conclusion. So what are the conclusions? Which all sides are opposite? 1 and 5 are opposite. 3 and 4 are opposite. 2 and 6 are opposite. These are the conclusions. opposite, not conclusion, opposite. Neighbors, you can certainly tell what all are the neighbors of 1. Neighbors of 1 is 2, 3, 4, 6. What all are the neighbors of 2? The neighbor of 2 is 2 and 6 are opposite, right? So apart from 6, everyone. 2 cannot come. And who all are the neighbor of 3? So neighbors of 3. 3 is opposite to 4. So apart from 4, everyone will come. 1, 2, 5, 6. That's it. Okay. Let's see more problems. An open cube is shown. Draw conclusion. So 3 and 5 are opposite. 3 and 5 are opposite. 2 and 1 are opposite. 2 and 1 are opposite. And 4 and 6 are opposite. You can try visualizing it now. You can try visualizing it. So let me show you the visualization. So this was 3, 4, 5, 2, 6, 1. So I just tilted it. 3, 4, 5, 2, 6, 1. Now what do? I push this 2, 6, 1 downward. 2, 6, 1 downward. This I have pushed downward. Then what do? I fold this 2, 6, 1. I have folded this in this manner. I hope you are able to visualize. And then I close the 1 from there. So 1 I cannot see. And then I put, this was the 4, 3. So I put 4 downward and then 3 below and I closed it. I hope you are able to see. Pushed and then in this manner and then pushed in this manner. First this was the scene, I pushed it, then I closed it, and then upper one I pushed it and then closed it from downward. That's it. Okay. So what did you get to know? From here what you can see? 6, 5 and 2. From here only 3 sides I can see. And I cannot see the opposite side. 4 and 6 are opposite. 4 and 6 are opposite. I told you 4 and 6 are opposite. I cannot see 4. This is what I have written, that this side would be 4. This side would be 1 and the below side would be 3. So I cannot see 4. 6 and 4 are opposite. 2 and 1 are opposite. 2 and 1 are opposite. So I can see only 1. Sorry, I can see only 2. I cannot see 1. And 5 and 3 are opposite. 5 and 3 are opposite. So I can see only 5. So at a time only one sides you can see. Only the side which are not opposite to each other. Basically 5, 6 and 2. These cannot be opposite to each other. Right? Because 5 and 6 are neighbors of 2. So how they can be opposite to each other? The opposite to 2 is only 1. Right? So only 3 sides you can see at a time. Now I will tell you two basic rules. Okay? Only 2 basic rules, and for the very first time I am asking you to remember something. These 2 rules I highly recommend you to remember. With those 2 rules you will be able to solve the problems very quickly. What are those 2 rules? If 2 numbers are common, this is the dice, this is this only. Okay, I have shown it in this manner. Basically this is this. This is this. I just have showed it in this manner, that there are. So from a dice you can see 3, 6 and 5, and here you can see 5, 3 and 4. Which 2 numbers are common? 3 and 5 are common, right? So from here you can make a conclusion that 4 and 6 are opposite to each other. 4 is opposite to 6. This is the only conclusion you can make. That's it. From these 2 configurations, the only conclusion you can make is that 4 and 6 are opposite to each other. So in 2 configuration, if you see 2 numbers common, that means the number that are left, those are opposite to each other. So these 2 are opposite to each other. That's the only conclusion. You cannot tell anything about 3 and 5. Anything about 3 and 5. Okay. These are opposite to each other. Certainly 3 is not the opposite of 4, 5 and 6. 3 is not the opposite of 4, 5 and 6. So 3 has to be opposite of 1 or 2. Now we don't know 3 is opposite of what. From 2 diagrams you cannot make a conclusion now that 3 has to be opposite of 1 or 2. So which is that we don't know. But 3 is certainly not the opposite of 4, 5, 6. Why is that so? Because 3 is neighbor of 4 and 5 and also 6. So it has to be opposite of 1 or 2. Same goes for 5 as well. That 5 is neighbor of 3, 4 and 6. 3, 4 and 6. 5 is the neighbor of 3, 4 and 6. So it cannot be opposite. So it has to be opposite of either 1 or 2. So if we were given one more diagram, from there we could make a conclusion that if 5 and 1 are opposite, that means 3 will be opposite to 2. So we need one more diagram to make a complete conclusion. So from this diagram we can make one conclusion, that is that if two numbers are common, that means 6 will be opposite to 4. So the rest of the numbers will be opposite to each other. Now if only one number is common, 1 and 1, so corresponding numbers will be opposite to each other. Corresponding number, you got it right. Left hand side of 1 is 4, left hand side of 1 is 3. So 3 and 4 are opposite to each other, and 5 and 6 are opposite to each other. Now only one number is common, 3, but the configuration is not same. So our target will be to make the configuration same. So what is the target? So in cube you can make any kind of rotation. You can make it clockwise as well, you can make it anti-clockwise as well. So to make the same configuration, what I will do, I will make the anti-clockwise rotation, right? 3 will go upward, so 5 will go downward, and 2 will go here. So anti-clockwise rotation is there. So 3 will go upward, 5 here, 2 here. Any rotation you can make. Even what do I mean to say is that, let us say 3, 6, 7. 7 cannot be there. 3, 6, 4. This is written. So if I make this rotation here, that 3 comes here, 6 goes here, and 4 goes here. Both are equal only. In cube you can make any rotation of the number. 3, 6, 4, 4, 3, 6. In this way it can keep on going. Okay. So any kind of rotation I made, if I had gone this way, then 3 would come here. This would not be of no use for, this would be of no use for me. If I had made this rotation, then 3 would come here. Still these are not same. Still these 2, 3 are not same. My target is to make the position of 3 to be same. So 3 is here, so now 3 is here as well. So what is the conclusion? That 6 and 5 are opposite. Corresponding number 6 and 5 are opposite, and 4 and 2 are opposite. 6 and 5 are opposite, and 4 and 2 are opposite. So these two conclusion only you have to remember. So in this first 23 minutes, what did we understand? There are only 3 rules. First one is that if any open box is made, then dropping one number, 2 will be opposite to each other. 3 and 5 are opposite to each other. 2 and 1 are opposite to each other. So rest of the numbers will also be opposite to each other. 4 and 6 are opposite to each other. Then if in the shown dice, we are given 2 common numbers, then the rest of the 2 numbers will be opposite to each other. And if only one number is common, then we have to make the orientation same. That if 1 is upward, so 1 should be upward. 3 is in this side, then 3 should go this side. We could do the changes in this dice as well. Let's just say if I had done the change in the first dice. So what I would have done? I would have made a clockwise rotation, right? So 3 would come here, 4 would come here, and 6 would go here. Now we would compare 4 with 2, because this was our other dice. This is 3, this is 5, and this is 2. So 3 and 3 are common. So 4 and 2 will be opposite to each other, and 5 and 6 will be opposite to each other. So any rotation you could have made, any kind of rotation. 5 and 6 are opposite to each other, 2 and 4 are opposite to each other. So any rotation you could have made, right? So these two are opposite to each other. Now which number is left? 1 and 3. So 1 and 3 are opposite to each other, right? 6, 5 opposite to each other, 4, 2 opposite to each other. That means 1 and 3 are opposite to each other. Or here also you can say that 3 is neighbor of 2, 5, 4, 6. 3 is neighbor of 2, 5, 4 and 6. So what does that mean? 3 is opposite to 1. That's it. Okay. Now ideally in the dice, if you have seen a dice that you use for Ludo, so in the dice, addition of opposite number are 7. Okay. The summation of the numbers on the opposite side is 7. So at the upper side, if you see 1, at the below there will be 6. If you see 4 at this side, then this side will be 3. If you see 5 at this side, then other side will be 2. So this is the ideal dice. But there is very rare chance that they will ask question from ideal dice. They can give any kind of dice. It's not necessary that 6 plus 1 will be there, 2 plus 4, 2 plus 5 will be there, or 4 plus 3 will be there. No. They can give any kind of dice. But if the question is something like that, in which way the dice can be opened? So dice means then you should consider ideal dice. and then you need to follow one rule, that is opposite side addition will be 7. Let's just say I have drawn this diagram, this open diagram. This is the open dice, 4 ideal dice. So is that a possible diagram? I am saying 1 is 6, then 2, 4, 5 and 3. Is this a possible diagram of an open dice? Open ideal dice, Is this a possible diagram? No, this is not possible, because here 1 is opposite to 6, that is good, but 2 cannot be opposite to 4. In ideal diagram, in ideal dice, 2 has to be opposite to 5. So this should be 5 here, 5 should come here, and then 4 would come here. So 4 and 3 are opposite. So now this diagram is correct for an open dice. Understood? So, but rarely open dice is problem is asked, like ideal dice problem is asked. Rarely they ask question from ideal dice. They will take any kind of dice and then they can ask you problems. Okay. Now what they are asking in this problem? You have to find the values of AB. Find the values of AB. So here what you can see, the number 1 is common. The number 1 is common. One number is common. So what I will do, I need to make the orientation same. So I will push this one here, and then 4 will go here and 6 will come here. So 6, 1 would come here and 4 would go here. So what did you understand from there? See the orientations. 3 and 6 are opposite to each other. 3 and 6 are opposite to each other. 2 and 4 are opposite to each other. 2 and 4 are opposite to each other. That means 1 and 5 are opposite to each other. This is the conclusion, right? Now what they are asking, what could be the possible value of A and B? So with 5, 1 can never come, because A and B are neighbors of 5. So if you can see 5, you can never see 1. So A and B can never be 1. So these 3 options are gone. Only option left is D. So it could be the case that A could be 2 and B could be 3, or A could be 3, B could be 2. It could be any case. They could be 4 or 6 as well, right? A and B could be 4 or 6 as well, but it can never be 1. So 3 options are gone. So it can never be 1, right? So this is the only possible option, that 5 can never be with 1. Okay, let's see the next question. Which number will be on top if 2 is at bottom? If 2 is at bottom, then which number will be on top? So how many numbers are common here? 4. But orientation is different. So what I will do, I will put this one as upward, this goes here and this goes here. So how will the orientation look like? The 4 goes up, 2 comes here and 1 comes here. And what is this orientation? This orientation is same, 4, 3 and 5. So what do you see? 2 and 3 are opposite to each other, and 1 and 5 are opposite to each other. So basically 2 and 3 are opposite to each other. These two are opposite to each other. So if one number is on top, then which will be on the bottom? The one which is opposite, right? So answer will be 3. If one number is on top, which will be at opposite? Bottom one. One number is on top, what will be at bottom? The opposite one. So answer will be 3, right? 2 is opposite to 3. Let's see this question. So in this question we are learning a new concept, so don't try to do it on your own. Just see the solution first. Okay, so we will learn a new concept. So I told you one thing, in dice orientation is always same. You can do anti-clockwise or clockwise rotation. So let's just talk about this point, not this point. I am just starting from 1. So if I go from 1 to 4 and 4 to 3, then I again come from 3 to 1. So in clockwise rotation, what do I get? 1, 4 and 3, right? So in the dice that I pack, these dice I have packed now. This was the open, this I have packed. So in the packed dice as well, if you go in clockwise direction, then you should get 1, 4 and 3. So in the dice, if I go in the clockwise direction, 1, 3 and 4. So in the clockwise direction, what I am getting? 1, 3 and 4. Here what I was getting? 1, 4, 3. This option is not possible. That after packing this, you cannot get this. So in this one, what they are saying? That I am going from 5 to 6, 6 to 3 and 3 to 5. 5 to 6, 6 to 3 and 3 to 5. In what clockwise direction? 5, 6, 3. Now let's pick 5. Okay, let's pick 5. So what I can do, I can make 5 here as well, because I told you that 5, all these 5 can slide, right? These 2 can slide here. 1 can slide to 4, 6 and 2. So 5 can also slide. So I am making 5 here. Although I could have started from here as well, that I need to go from 5 to 6 and then from 6 to 3. So from here only I am getting to know that, and then 3 to again 5. Here only I am getting to know that this is clockwise rotation only. So in clockwise direction, what you are getting? 5 to 6 and 6 to 3. So in clockwise direction you are getting 5, 6, 3. Here also you are getting 5, 6, 3. Why I made it here? Because it would be simpler to see. 5 to 6, then 6 to 3, and then 3 to 5. Just a simpler, it would be a bit simple. But from here also you can check. So 5 to 6, 6 to 3. Now you will say that, sir, from 5 to 2 also you will get. In clockwise direction, I could have written this as well, that from 5 to 2 I will go, from 2 to 6 I will go, and then again 5. 5 to 2, 6, 2 to 6 and again 5. Yeah, this is also correct. But 5 to 6 all together you cannot see on any dice. So why should we see this? The question is, after folding, which one you will get? So we should see what is common. So next what I can see? 5 to 2, 2 to 4 and 4 to 5. So if I start from 5 to 2 and then 4. So where will 4 come? 4 can come here as well. Say yes or no? Because 2 and 4 are neighbors. 2 and 4 are neighbors, they are not opposite to each other. 2 and 4 are neighbors, they are not opposite to each other. So 4 can come here as well, no? Basically, you can clip off any of the face and then stick it here. Basically, they were neighbors. So what did I do here? That 4 I opened that side, 2 I opened that side. What I could have done? 2 and 4 I have opened all together to the back side. So this is what I would have got. You can clip off anything from upside, okay? Anything. You could have clipped off 3 also here. I could have clipped off 3 as well here. This also I could have done. But I need 2, 4 and 5 together. So I will start from 2. I need to move in clockwise direction. I could have moved in anti-clockwise as well. Let's just say I will put this one in anti-clockwise. And I can start from anywhere. Let's just say I start from 5. I am moving in anti-clockwise. So 5 to 4, 4 to 2 and then 2 to 4. In anti-clockwise we have to move. So starting from 5, anti-clockwise, 5 to 2, 2 to 4 and then 4 to 5. So in anti-clockwise what do you get? 5 to 2 and then 2 to 4. And here what you were getting in anti-clockwise? 5 to 4 and then 4 to 2. 5 to 4, 5, 4, 2. Not correct. Same goes for this one. You can start from any number and you can move clockwise, anti-clockwise in any direction. Let's move anti-clockwise from 4. 4 to 1, 1 to 2 and 2 to 4. So in anti-clockwise, what you are getting? 4 to 1, 1 to 2. So where is 2? Sorry, where is 4? From 4 we need to start. And 4 and 2 should be together. 4, 1, 2. I need 4, 1, 2 together. 4, 1, 2 together. So what I can make? This was your 4. I can get this 2 upward. So 2 will be here. I told you I can get this 2 upward. And 1 I can slide anywhere. So 1 I can get here. 1 I can slide anywhere. So I need to start from 4. And in what direction? In anti-clockwise direction. In anti-clockwise direction. So 4 to 2 and then 2 to 1. So in anti-clockwise direction, what you are getting? 4 to 2 and then 1. 4 to 1 you are getting. 4, 1, 2. This is also not correct. So always if these kind of questions are given in the examination, this was one of the best question of SSC, I guess. This question was asked in SSC CGL. So the best question. The only concept here is that the orientation always remains same. Clockwise direction if you move. So here also if you move the clockwise direction, you should get the same numbers. So only in the clockwise direction 5, 6, 3, 5, 6, 3 we are giving. And you can rotate from any number to anywhere in any direction. From 4 to 2, 2 to 1 in anti-clockwise also we moved. Then we got to know we are getting 4 to 1 here and 4, 1, 2 here. So these two dice are not same. If I pack this dice, I will never get this dice. I will never get this dice. Only this dice I can get. Understood? Well and good. Everything is crystal clear. Now we will see the problem which was asked in GATE this year only, in 2024. In 2024 they asked a question on dice. So three different die views are shown, which piece of paper can be folded to make this dice. So let's see the first two. Here what do we see? 4 and 4 are common, right? 4 and 4 are common, but orientation is not same. So what I will do? I will make the orientation same. So 4 comes here, 6 goes here, and 3 goes here. 4 comes here, 6 goes here, and 3 goes there. So what did you understand from here? 5 and 3 are opposite to each other, and 1 and 6 are opposite to each other. So what is left? 2 and 4 are opposite to each other. So this is what we need to pick. 5 and 3 are opposite to each other. 5 is opposite to 3. 5 is opposite to 6 here, wrong. 5 is opposite to here, wrong. 5 and 3 are opposite to each other. Okay, this can hold. 1 and 2 are opposite, but actually 1 and 6 are opposite. So this is also wrong. Here we can check. 5 and 3 are opposite, yes. 1 and 6 are opposite, yes. 2 and 4 are opposite, yes. That's it. So this was the question. So only in 30 minutes you are able to solve these kind of problems with the 30 minutes of concept. Actually in the examination in 30 seconds you will be able to solve. But with the 30 minutes of concept, you are able to solve the problems now. Well and good. So our dice chapter is completed. Now we will move to cube. Okay. So dice is completed. So let's solve a problem on cutting of a cube. You are cutting the cube now. Okay. So what is given in the problem? That there is a cube. The side is 5 centimeter. The each side is 5 centimeter. And then you are cutting in some small parts of side 1 centimeter. From the cube you are getting a cube. From this cube you are getting one cube which is of side 1 centimeter. This is what you are getting. This is what you are doing. So how many cubes you can get, how many cuts you need to make, how many cubes will be 2 side painted, 3 side painted. These are kind of questions they are asking. So from this this is what you are getting. So what is the first question? How many such cubes will be there? So if I make a cut, let's just say, how did I make this cut? I will explain. Okay, no need to worry. How did I make this cut? I will explain this. But if I have made the cut, so this will be the cube of 1 centimeter side, right? 1 centimeter, 1 centimeter, this will also be 1 centimeter, and the breadth will also be 1 centimeter. This complete also is of 5 centimeter, 5 centimeter. Here, one cube I will get 1 centimeter, 1 centimeter, and 1 centimeter, right? So how many such cubes will be there? How you can find it? So you get n number of such cubes. You get n number of such cubes. Okay. So, but the thing is their volume will remain the same. Let's just say the volume for this was 5 into 5 into 5. Yes. Do you remember the volume of a cube? A cube. Now the volume of this small cube will be 1 into 1 into 1. Volume of this small cube will be 1 into 1 into 1. And there will be total n cubes. All the volumes combined will be equal to this volume only. Right? Say yes or no? Because in a box of 5 centimeter, 5 centimeter, 5 centimeter, 1 centimeter, 1 centimeter, 1 centimeter cube can be put n times. In a box of 5 centimeter, cube, 1 centimeter cube can be put n times, right? If I put 1, 2, 3, 4, 5. So the volumes are same for the n 1 centimeter cube volume. For n 1 centimeter side cube. So value of n will be 125. You just need to equate the volumes because volumes will be same. So in a box of 5 centimeter, side, there can be 125 boxes which has the side of 1 centimeter. Say yes or no? Well and good. These kind of questions in mensuration we have solved. Volumes equated. Now what is the next question? How many cuts you need to make? So this was the box. How many cuts I had to make? So let's just say I was given a paper of 5 centimeter and I was asked, what people asked me, that you need to get me 1 centimeter, you need to get me a page of side 1 centimeter. Here both sides are 5 centimeters. So how will I do it? I will make 1 cut, 2 cut, 3 cut and 4 cut. So in 4 cuts only, what I have got? These papers I have got. This side is 1 centimeter only. In 4 cuts only, I have got 5 sides, right? In 4 cuts, I have got 5 paper. So one less cut I had to make. If this was the paper and I was asked to get 2 cuts only. I was asked to get 2 pages. So what I would do? I will make a cut from here. So for 2 I need to make 1 cut. For 3 I would have to make 2 cuts. For 4 I would have to make 3 cuts, and for 5 I have to make 4 cuts only. So after 4 cuts I am getting 5, right? 1 1 1 1 1. Now I need to make cut here as well, right? Because I need 1 centimeter, this also 1 centimeter, and then this would be 1 centimeter and this would be also 1 centimeter. So 1 cut, 2 cut, 3 cut, 4 cut. So after that I am getting this side which has 1 centimeter, 1 centimeter, 1 centimeter and 1 centimeter. Same with this side, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. So same goes here, right? So 4 cuts here, 4 cuts downward. So in a square there is only length, and this is this you can say height, but there is no breadth. So in a cube you have to make the cut along with the breadth as well. Look, if I call this as height, so 1 cut was along the height, the blue one is along the height, right? Blue one is along the height. Do you agree to my point? Along the height, this cut is along the height. Along the breadth also you need to make the cut. So this is along the breadth. No, this is not along the breadth, this is along the length. If this is length, so this green one is along the length, the green one is along the length, and the brown one is along the breadth. It is cutting the breadth. So length, breadth and height all are of same side, but there are 3 dimensions: length, breadth and height. So along with everyone you need to make cut. So basically how many cuts are there? 4 into 4, sorry, 4 plus 4 plus 4, sorry, 4 plus 4 plus 4. So along everything, so 3 into 4 you can say, or you can say 3 into the number of side, the length of the side. The length of side was 5 centimeter. The length of the side was 5 centimeter, and if you need to get 1 centimeter of each side, you need to make 1 less cut. So 3 into 5 minus 1. Or you can say, if the length of this side was, let's just say 10 centimeter, then how many cuts you had to make? 9. So 9 along the length, breadth and height. So 3 into side a minus 1. 3 into a minus 1. 3 into a minus 1. This would have been 3 into a minus 1. So in the question, if they are asking how many such cuts you need to make, so answer would be 3 into a minus 1. If you can remember it, you can remember it, but I recommend to do the calculation in the examination with your basic aptitude only, because they are not going to give a side of 196 like that. No, nothing like that. You will be able to do the calculation. You will not have to apply the formula. Because if this question comes, what you will do? You will quickly draw a cube, and then you will say that, okay, I need to make 1 centimeter cube. So 1, 2, 3, 4. 4 cuts I need to make along every side I will make. Length, breadth and height. So 4 cuts, 4 into 3, 12. This would be my answer. That's it. So in the examination, you will not have to think that much. Okay. And in the PYQ as well, we are solving one problem which was based on this only. So there I have also solved without using any formula. So we will not use any formula. Now, which is the next question? How many cubes will be 3 side painted? So what they are saying, that a 5 centimeter cube, as cube of side 5 centimeter is painted as well. So this is painted from outside, right? This is painted from outside. This side would have also been painted. This side would have also been painted. So these are painted from outside. We cannot paint it from inside, right? If I am painting this, it will be outside. It will be painted from outside only. So which side will be 3 side painted? These only, the corner ones only. Say yes or no. The one which is on corner, these will be three side painted. 1, 2 and 3. How many sides will be painted for this one? 2. How many sides will be painted for this one? 2. 2. What about this? 3. Another one that side as well. So one which is on corner, 1, 2, here as well, 3 sides will be painted. The below one will also be painted, right? These two are there and the below one. Basically, these 2 sides are there, 1 and this is 2, and also the below one will also be painted. So 3. And in this one we can directly see 1, 2 and 3. 3 sides are painted. Let's just say this is a cube of 1 centimeter. 1, 2 and 3. So all those which are on the corners, or you can say which are on the vertex. This is vertex, 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 vertex. So how many vertex are there? This we have already seen in geometry and mensuration. So in a cube there are 6 faces. 6 faces are there, 8 vertex. Vertex means this. Faces means the walls you can see 1, 2, 3, 4, 5, 6. Vertex means the corners 1, 2, 3, 4, 5, 6, 7, 8. And edges means this line edge. Edge. In cricket we have seen, right, outside edge. So outside edge means, let's just say this is bat. So here the ball has struck. Outside edge and gone, right? If the ball strikes here and someone catches it, right? So this is what we tell edge. Edge लग गया, बोलते हैं ना बहुत बार क्रिकेट में, edge लग गया था. So this is known as edge. So this will be the edge. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see in your room as well, there will be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges are there. So what is the matter of concern for us? That 3 side painted will always be 8. Now this could be any, the box could be of any size. Let's just say if the box was of 10 centimeter and again we made a cut of each 1 centimeter, then still the answer for 3 sided painted will remain the same, because only on the vertex only here, these ones only will be 3 side painted, right? Only these will be 3 side painted. 3 side painted. So what would be the answer? 3. Very simple. And I can show it here as well so that you don't get confused. Sorry, why did I write 3? Sorry, answer would be 8. There are 8 vertex, no? 1, 2, 3, 4, 5, 6, 7, 8. Answer would be 8. Sorry. There are 8 vertex. One, 2, 3, 4, 5, 6, 7, and 8. Right? Let's see the next one. 2 side painted they are asking. 2 side painted. So where will be 2 side painted? Here, here, and here. Here also 2 side painted will be there. Here also 2 sided painted will be there. Here also 2 side painted will be there. This would be 3 side painted. 2 side painted, 2 side painted, 2 side painted. This is also 2 side painted, 2 side painted, 2 side painted. Here also 2 side painted, 2 side painted, 2 side painted. What about this one? This is also 2 side painted, 2 side painted, 2 side painted. Right? On each corner you are getting 2 side painted. This will also be 2 side painted, 2 side, not on corner, sorry. On each edge you are getting 2 side painted, right? On each edge you are getting 2 side painted, but not this, not these two. These two will be eradicated. These two will be eradicated. This one and this one. So if my side was of 6 centimeter, let's just say if my side was of 6 centimeter, then 2 will be eradicated. That means 4 I will get from one corner. 4 I will get from one corner, right? If it was of 6 centimeter, I would get 4 from one corner. And how many such corners are there? 1, 2, 3, 4. You can see 1, 2, 3, and 4. How many such corners are there? 4. So 4, 4, and 12 corners are there. So 4 into 12. This would have been the answer, 48, if it was of 6 centimeter. But the side is of 5 centimeter. Then you are getting 3 from here, 3 from each corner. So 12 into 3 is the answer. 12 into 3 is the answer. That is 36. And if you allow me to draw it again, I can show in this diagram as well that from each corner you are getting, sorry, not from corner, from each edge you are getting. How many edges are there? 1. Basically from here you will get, 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 from here, from here. Basically the complete one, basically. Here, here. So 12 are there. So 12 into 3, or you can say 12 into a minus 2. Say yes or no? 12 into a minus 2. 12 into a minus 2. Why is that so? 12 into a minus 2, because I told you if it was 6 centimeter, then this and this would have been gone. So a minus 2 from 6 centimeter, this and this would have been gone. The side was of 6 centimeter, this would have been gone. Into 12 edges are there, so a minus 2, 12 into a minus 2. That's it. Okay, let's see the next one. How many cubes will be two side painted is gone? How many cubes will be one sided painted? One side painted. What do you think? One side painted. This one, 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 and this one. So from one face, how much you are getting? 3 plus 3 plus 3. So from one face you are getting 9. How many such faces are there? On face only one sided painted will be there, no? On the face, 3 plus 3 plus 3 you are getting. And how many such are there? Into 6. So 9 into 6, 54 is the answer. And if the side was of 6 centimeter, then this complete one would have been gone. This and this would have been gone. So 2 would have been gone. And then how much you would have got? 4 plus 4. Basically this, and this. These 4s would have been gone. Basically 4, 4, 4 and 4. Are you able to visualize how much you will get from one face? This upper one, this one, this one, this one and this one would have been gone. Because this will give you 3, 3, this will give you 2, 2, 2, this will give you 3, 3, 2, 2, 2, 3. So these would have been gone now. And this will also be gone, 2, 2, 2, 2, 2, 2, these 2. So in each face, 4 plus 4 plus 4 plus 4. So basically 4 into 4 you would have got. And then how many faces are there? 6. So what is the answer? 6 into a minus 2 square. Because here also you are getting 3 into 3. If the side was of 7 centimeter, you would have got 5 plus 5 plus 5 plus 5 plus 5. So a into 2, sorry, 5 is added 5 times. So what would it would be? 5 square. 6 would have been added 6 times, so it would be 6 square. So a, if the side was of a, then a minus 2 square, and on the 6 faces you will get. So a minus 2 square into 6. That's it. Okay. So I will write it down. So 3 plus 3 plus 3. On one face I am getting 3 plus 3 plus 3 into 6. So that would be 6 into 3 square, 54. Look, I could have directly written the formulas as well, then I could have proved it. But let's first prove it and then write the formulas. I am also telling you from where the formulas came, right? So if the side would have been a minus 2, I know it is not that easy to visualize. And if this question comes in the examination, not everyone will be able to solve it. Rest of the aptitude problems are easy, but not this cube one that I know. Cutting the cube is not that easy. So if you have done the problem, you will be able to solve. So understood this point? From one side you will get a minus 2 square. From one face you will get a minus 2 square. So there are 6. So 6 into a minus 2 square. Right? Let's see the last. What is that? How many cubes will be unpainted? So you can directly do how many total cubes were there? 125. Then you can subtract 3 side painted, 2 side painted and 1 side painted. So this is what you can do. Minus 8, minus 36 and minus 54. What you will get as answer? You will get as answer as 27. Now let's see how you could have done it in better way. So if you are able to visualize, just below this there will be a cube. Just below this cube there will be a cube which is inside, which is not painted. Just below this also there will be a cube which is not painted. Just below this also there will be a cube which is not painted. So 3, and again in this row as well, in this row as well, and in this row as well, there will be 3, 3, 3. In these rows there will be 3 plus 3 plus 3. There will be 3 plus 3 plus 3. And then into 3. Then into 3. Because the same will happen this side as well, this side as well, and this side as well. So 3 plus 3 plus 3, then into 3. 3 plus 3 plus 3, and then into 3. basically this line and this line. So these many are there which is unpainted. Understood? Let's do it in better manner. If the side was of 4 centimeter, if the side was of 4 centimeter, so how many below this you will get? 4. 4 plus 4 plus 4 plus 4, and how many times? 1, 2, 3 and 4 times into 4. So what would have been the answer? 4 into 4 into 4. That means the answer would have been 4 cube, or you can say a minus 2 cube. Here what is the answer? 3 plus 3 plus 3 into 3 times. So answer is 3 into 3 into 3. So you can say a minus 2 cube. So similarly the answer is a minus 2 cube, or the way is 3 plus 3 plus 3 into 3 times. So without calculating all these, we can directly write that would be 3 plus 3 plus 3 for how many times? 3 times. So answer would have been 3 into 3 square, or you can say 3 cube, that would be 27, or the formula could have been a minus 2 whole cube. Okay, so these are the formulas. This is the complete analysis of this problem, that how many sides will be 3, 2, 1 side painted, and how many total cubes will be there, right? And how many cuts you need to make. So this is the final formulas. The number of cuts you need to make is 3 into a minus 1, right? Along the length, breadth and height, you need to make 3 cuts, and that would be a minus 1, because side is of 5, so you need to make 4 cut. So 4 cut along length, breadth and height. So that's why this 3 is there and a minus 1. A is the length of side. 3 side painted will be 8 only. 8 vertex are there. 1, 2, 3, 4, 5, 6, 7, 8. It would be 8. 2 side colored. 2 side colored. So on each faces you will get, that you will get is a minus 2. Sorry, 2 side colored you will get on edges. On edges you will get 2 side colored. Right? So that would be a minus 2 into 12. 12 edges. 1 side color you will get on faces. So that would be a minus 2, a minus 2, a minus 2. Basically a minus 2 square. The 3 plus 3 plus 3. It would have been 4 plus 4 plus 4 plus 4. So 4 square. So in one face you are getting a minus 2 square. So in 6 faces you will get 6 into a minus 2 square. What about no side color? That would be in between the cube. So 3 plus 3 plus 3 into 3. If it would have been 4, then 4 plus 4 plus 4 plus 4 into 4. So answer would be a minus 2 cube, and total cubes are a cube only. How many total cubes are there? That is a cube. Why a cube? Because the total volume, let's just say the total volume, the side is of, let's just say the side is of 10 centimeters. So total volume will be 10 cube, and then n number of cubes will be there each side of 1 centimeter. So n will be 10 cube only, or you can say a cube. So total number of cubes will be a cube. So these kind of questions can be asked, and you should have a good aptitude how to solve these kind of problems and how to think in this manner. Okay, so this 20 minutes would have been very beneficial to you for this cube kind of problems. Okay, then thank you very much. Now your dice and cubes are completed. Okay, thank you.